Hello everyone, welcome to Saimedha Koti, Hyderabad. In this video, I would like to discuss class number 11 auto transformer. In this topic, I will discuss short notes and concept through the questions. First one, we will discuss about short notes, and after that some practice question based on this topic. So this class is useful for Andhra Pradesh State Electricity Board AEE exam and also Telangana Genco Transco Discoms AE exams. Let's start from the short notes, and after that we will discuss some concept through the questions. First one, short notes from the auto transformers, and this one is short notes from auto transformer. Short notes from auto transformer, and this short notes is also called key points from auto transformer or observations from auto transformers or possible questions from the auto transformers part. So these are all possible questions, observation, key points and short notes from auto transformer. And one of the question, first question here, or first point, first observation from the auto transformer. Auto transformer is a single winding transformer. Auto transformer is a single winding transformer. Single winding transformer in which some part of the winding, in which some part of the winding electrically connected. Part of the winding electrically connected between the source and the load. Source and the load, whereas remaining part of the winding electrically isolated between the source and the load. So this is the definition of auto transformer, and auto transformer is a single winding transformer in which some portion of the winding or some part of the winding electrically connected between source and the load, and remaining part of the winding electrically isolated between the source and load, as shown in the as like two winding transformers, as like the two winding transformers point of view. Okay. And next one, in auto transformer, power transferred from the source to the load by two ways. One is induction power and second one is conduction power. And next one, in auto transformer is equal to, that is input power of the auto transformer is equal to, so that is induction the power plus the induction power plus conduction power. So conduction power of auto transformer, conduction power. So now this also equal to output power of auto transformer here. Always the input power of auto transformer, this auto transformer part. So in auto transformer, input power of auto transformer is equal to induction power plus conduction power and output power of auto transformers. And next one, the third observation, see here, sometimes we have a question, how do we calculate the induction power? The induction power of auto transformer is equal to induction power, and it is also called induction kV of auto transformer. Induction power of auto transformer is equal to 1 minus k times of, okay, 1 minus k times of the input power of the auto transformer, 1 minus k, where k is a transformation ratio of auto transformer. And next fourth one, so that is conduction power is equal to conduction power of auto transformer is equal to, so K into, so input, the power or input kVA of auto transformer, input kVA of auto transformer here, where K is a transformation ratio. So in this case, where the K is nothing but the transformation ratio, transformation ratio of auto transformers here. Sometimes we have a question about the K. K is transformation ratio of auto transformer or tapping position of the auto transformer. Another name of this one. So that another observation, fifth one. What about the K? So that is where K you can call it as, the K is the transformation ratio of auto transformer, and sometimes it is also called the tapping percentage or tapping position of the auto transformers, point. And how do we find out the K? Always K of auto transformer is equal to low voltage of auto transformer divided by high voltage of the auto transformer. High voltage of auto transformer. This is the value of the K. Or K is always the low voltage of auto transformer divided by high voltage of auto transformer. And how do we find out the K? Sometimes we have a question here. And range of the K. So how do we get range of the K in auto transformers? So K is greater than 0.33 and less than the 1. So this is the range of the K. And sometimes we have a question, desirable value of the K. So this one is the desirable value of the K here. So it is always nearer to the 1. So for example 0.909 like. So this one is desirable value of the K. And next one, economically. So sometimes we have a question, economically value of the K, value of K is equal to 0.5. సో ఏదైనా క్వశ్చన్లో కే గురించి ఇవ్వలేదు అన్నప్పుడు మనం ఏ వాల్యూ తీసుకోవాలంటే ఎకనామికల్ వాల్యూ తీసుకోవాలా. సో సపోజ్ సమ్ టైమ్స్ క్వశ్చన్ చేసేటప్పుడు ఆ వాల్యూ ఆఫ్ కే ఫైండ్ అవుట్ చేయడానికి ఎలాంటి డేటా అనేది ఇవ్వడు. మరి అలాంటప్పుడు కేని ఏ విధంగా కనుక్కోవాలంటే జనరల్గా ఎకనామికలీ వాల్యూ ఆఫ్ ద కే ఈజ్ ఈక్వల్ టు 0.5 అనుకొని క్వశ్చన్ చేస్తే సో యూ విల్ గెట్ ఏ ఆన్సర్. సో ఇది ఒక క్వశ్చన్. అండ్ హౌ డు వి ఫైండ్ అవుట్ ద వాల్యూ ఆఫ్ ద కే. And next one, sometimes we have a question that is sixth observations here, sixth possible question, weight of the comparisons point of view, weight comparison between single phase two winding transformer and single phase auto transformer point. So that is weight of, okay, this weight of auto transformer the is equal to weight of copper material in auto transformers. Okay, this weight of copper material in auto transformer is equal to 1 minus K times of the weight of the copper material, weight of copper material in the two winding transformer. So this one is weight of the copper material in the two winding transformer. This type of the question. And next possibility of the question here, saving of the copper, comparison point of view, how much amount of the copper is saved. So that is the saving of copper material. So this copper, the material is equal to, so this one in case of saving of copper material is equal to the K times of the here weight of the copper in two winding transformer, weight of the copper material the in two winding transformers. So this is also one more question, where saving of the copper. And next one, percentage losses of the auto transformers. Sometimes we have a question, and this is the eighth observation here. The losses of percentage losses of auto transformer, the percentage losses in auto transformer is equal to percentage loss in auto transformer. So that is equal to 1 minus k times of the percentage losses in the two winding transformers. Here comparison, suppose if the auto transformer is obtained from the two winding transformer, so here percentage losses of auto transformer is equal to 1 minus k times of percentage losses, but total losses of, okay, this total the losses of auto transformer is equal to total losses of the total loss of the two winding transformer. This is a very important. Percentage losses are equal to 1 minus k times of the percentage, 1 minus k times of percentage losses in that auto transformer. And next one, percentage resistance of auto transformer is equal to the 1 minus k times of percentage resistance in the two winding transformer. And percentage the reactance of auto transformer is equal to 1 minus k times of percentage reactance of the two winding transformers. Look at this type of the question. And that 11th point, percentage impedance of auto transformer is equal to 1 minus k times of percentage the impedance of the two winding transformers. And 11th point, 12th points here, percentage voltage regulation, okay, percentage voltage regulation in auto transformer is equal to 1 minus k times of the percentage voltage regulation of two winding transformer. And one more important point, so 13th one, the KVA rating of auto transformer here, very important one, the KVA rating of auto transformer is equal to 1 by 1 minus k times of, okay, KVA rating of the rating of two winding transformer. So this type of the question. So percentage impedance, percentage reactance, percentage losses, voltage regulation and KVA rating. So these are all conclusions from auto transformer point of view. So now conversion of auto transformer from the two winding transformer is obtained by using two ways, such as the series additive polarity of auto transformer, and second one is series subtractive polarity of auto transformers. So conversion of another one, conversion of auto transformer, the 14th points here, conversion of auto transformer. Conversion of auto transformer from two winding transformer is obtained from, okay, obtained from the two winding transformer. Conversion of auto transformer from one to is obtained by two ways, by two methods, such as one is a series additive polarity of auto transformer, additive polarity of auto transformer, and second one is series subtractive polarity of auto transformer. Second one is the series subtractive polarity of auto transformer point. So in series additive polarity of auto transformer, so two windings, primary winding and high voltage winding and low voltage winding of auto transformer are connected in series in such a way that net voltage will be added off. And similarly in series subtractive polarity of auto transformer, HV winding and LV winding of the two winding transformer are connected in series in such a way that net voltage will be subtracted. So like this manner. So next fifth observation here. So that is series additive polarity. So what are the voltage and current equation? Let us calculate series additive polarity of auto transformer point. Suppose in series additive polarity of auto transformer, so this one is, let us assume LV winding. So these are ELV1. So these are low voltage of the two winding transformer, and this one is the HV winding. So high voltage of the two winding transformer. These two windings are connected in series. Suppose, so if it is a dot here, so this one is the dot, and here also dot. So now like this, these two are connected in series additive polarity. And this connections point of view, suppose applied voltage V1 and current in the auto transformer I1. So this current you can call as I2 here, and this current you can call I2, and load terminal voltage. So this is the load terminal voltage, okay, like this. So this type of the polarity connection is known as series additive polarity 1. So in this case I2 and V2. So V1 is a input voltage of auto transformer. So this is the input voltage, and these are source. So we can call this one is the source of auto transformer, the source, and this is the load of auto transformer. So this E here ELV and EHV. So this current point of view, so current in the LV winding, and this current is a current in the HV winding of auto transformer. So in series additive polarity of auto transformers, here first one, what are the conclusions we have? So in series additive polarity of auto. So how do we get V1? So that is input voltage of auto transformer. It is denoted by V1. So E1 is equal to EHV. So if it is excited with the high voltage, and next one, input current of auto transformer, it is denoted by I1. So now this current, just apply the KCL at this point. So that is equal to ILV, okay, plus IHV value. And next one, output voltage, okay, voltage of auto transformer, and this output voltage of auto transformer is equal to, so a voltage V2. So this value is equal to output voltage. This is two windings are added in series additive polarity, so that net voltage will be added up. Here V2 is equal to the EHV plus, okay, ELV value. And next one, output current of, okay, this output current of auto transformer. So that I2 is equal to the same amount of the current passes through here, so that is equal to IL. So from here we can get, so this one is input voltage, and here the input kVA of auto transformer. How do we get input kVA of auto transformer? From this. So from here input kVA is equal to V1 multiplied by I1. And next one, output kVA of auto transformer. So this value is equal to V2 multiplied by I2. So here suppose transformation ratio, or transformation ratio auto transformer is always low voltage of auto transformer divided by high voltage of auto transformer span. Always we have to calculate by low voltage by high voltage of auto transformer. So this is series additive polarity equation. సో ఇలాంటి డయాగ్రామ్ ఇచ్చినప్పుడు క్వశ్చన్ అడగొచ్చు, లేదా డైరెక్ట్గా ఇలా క్వశ్చన్ అనుకోవచ్చు. ఇన్పుట్ వోల్టేజ్, అవుట్పుట్ వోల్టేజ్, input current, output current, input kVA of auto transformer, and also output kVA of auto transformer. Always input kVA is equal to output kVA of auto transformer. But if you find out the K, we can find out induction kVA, conduction kVA of auto transformers. And next 16th observations here, and that is series subtractive polarity of auto transformer. The series subtractive, the polarity of auto transformers. How do we get series subtractive polarity of auto transformers? Fine. And series subtractive polarity of auto transformers find up two windings. So I'm assuming here, so this is the HV, high voltage of the two winding transformer, and this is low voltage of ELV, low voltage of the two winding transformer ELV. and these two are connected in series additive polarity. So like this manner, series additive polarity of, so dot E is here, suppose this one is the dot, and suppose E windings unkondi, the A and A winding, and this is a B winding, and this one is the C part and it is a D. Here is one, A is a dot, D is a, B is undotted, C is okay, A is a dotted, A and D are connected, connection relation A and D are connected, and B point is a common between source and the load. ఇలాంటి క్వశ్చన్ కూడా అడుగుతాడు. సో దీని నుంచి A and D are connected, సో కనెక్టెడ్ అని అంటే ఈ విధంగా ఉంటుంది. సపోజ్ నేను దీన్ని ఏ వైండింగ్ టూ వైండింగ్ ట్రాన్స్ఫార్మర్ తీసుకుంటే, సో ఏ బి ఒక దిస్ వన్ ఇస్ ద సి అండ్ డి, సో ఇలా ఇలా ఉన్నది వైండింగ్ పాయింట్ ఆఫ్. ఇప్పుడు ఎలా కనెక్ట్ చేశాను, టూ ఆటో ట్రాన్స్ఫార్మర్ రావాలంటే ఏ అండ్ డి టెర్మినల్స్ ఆర్ కనెక్టెడ్ and B point is the common between source and the load, A and D are connected, so and B is common, so B is a common point, so between the source and the load, so ee vidhanga connect cheyచ్చు. And next దీంట్లో కూడా సేమ్ ఇలానే A and suppose ఇది A and suppose నేను దీన్ని B పాయింట్ అనుకుంటాను, సో నేను దీన్ని A పాయింట్ అనుకుందాం. సో ఇప్పుడు దీని ద C పాయింట్ ఒక ఇయర్ సి పాయింట్ అనొచ్చు, లేదా ఇప్పుడు ఏ అండ్ బి పాయింట్ తీసుకున్నప్పుడు సో మనకు ఎస్ ఇప్పుడు ఏ అండ్ బి పాయింట్స్ తీసుకున్నాను. సపోజ్ ఇయర్ ఏ అండ్ దిస్ వన్ ఇస్ ద బి పాయింట్స్, ఏ ఇస్ ద డాటెడ్ అండ్ ఇన్స్టెడ్ ఆఫ్ ఇయర్ ఐఎమ్ కనెక్టింగ్ సి అండ్ దిస్ పాయింట్ ఇస్ ద డాట్, సి ఇస్ ద డాటెడ్ దిస్ two. So this type of the polarity connection is also we can call it as the series subtractive polarity of auto transformer antam. So ఇప్పుడు కరెంట్ ఏ విధంగా ఉంటుంది, సో దిస్ కరెంట్ సో ఇలా వస్తుంది. సో ఈ కరెంట్ అనేది మన కరెంట్ డౌన్వర్డ్ డైరెక్షన్ అప్వర్డ్ డైరెక్షన్, అండ్ దిస్ కరెంట్ దిస్ వన్ is a ILV or I2 and this polarity is a V2 and the V1 and the same currents we have. So suppose this current is equal to I1 component of the current. And next, how do we get input kVA? So that is input voltage of auto transformer 1. Input voltage is equal to EHV and input current is equal to, current will be subtracted. Input current of auto transformer I1 is equal to, it is a V1. I1 is equal to ILV minus IHV. ILV is a more. And next one, output current of auto transformer is equal to I2, so that is I the LV, and output voltage of auto transformer is equal to, so we can connect output voltage of auto transformer V2 is equal to, voltage will be subtracted EHV minus ELV, and input kVA of auto transformer, input kVA of auto transformer, it is equal to V1 into I1, and output kVA of auto transformer is equal to the V2 multiplied by I2. So these are the, so ఇలా కూడా కనెక్ట్ చేస్తూ రివర్స్లో కూడా నేను ఏం కనెక్ట్ చేసిన, ఏ అండ్ సి ఆర్ కనెక్టెడ్ అండ్ బి పాయింట్ ఈజ్ అ కామన్ బిట్వీన్ సోర్స్ అండ్, అలా కాకుండా ఇక్కడ ఏ అండ్ డి అండ్ బి కూడా కనెక్ట్ చేసి ఆ రివర్స్లో కూడా కనెక్ట్ చేయొచ్చు. సో ఇలా మనకు ఇది కనెక్షన్ పాయింట్ ఆఫ్ వ్యూ, ఏ అండ్ ద సి ఆర్ connected and B point is common. B is common point between the source and the load. So there are two ways to realize the auto transformer from the two winding transformer. One is the series additive polarity of auto transformer. Second one is the series subtractive polarity of auto transformer. And ఇవే క్వశ్చన్స్ అడుగుతాడు, ఎలా ఇచ్చినా కూడా నీకు డయాగ్రామ్ పైన కానీ input voltage of auto transformer, input current of auto transformer, output current, output voltage, input kVA and the input output kVA of auto transformer span. And next observation, so what are the applications? The seventh one, applications of auto transformer span aduguతారు. So what are the applications of auto transformer? One of the application, auto transformer is used as a variac to vary the supply voltage. Auto transformer is used as variac to vary, so used as a variac that to vary the supply voltage vary the supply voltage. సో ఇలాంటి క్వశ్చన్స్ అడిగే ఛాన్సెస్ ఉంటాయి. అండ్ నెక్స్ట్ అప్లికేషన్ ఏంటంటే ఆటో ట్రాన్స్ఫార్మర్ యూజ్డ్ యాజ్ ఎ స్టార్టర్, ఒక స్టార్టర్ టు లిమిట్ ద స్టార్టింగ్ కరెంట్ ఆఫ్ ద 3-phase ఇండక్షన్ మోటార్. ఆటో ట్రాన్స్ఫార్మర్ ఈజ్ యూజ్డ్ యాజ్ starter of 3-phase induction motor, 3-phase induction motor to limit starting current, to limit the starting current of the motor. And next one, auto transformer is used as a voltage booster in HVAC transmission system. And third one is auto transformer is used as voltage booster to voltage boosters in HVAC transmission system to maintain the constant voltage profile from sending end to the receiving end. So this is the one of the question. So what are the applications of auto transformers? And next observation, what is the limitations? Okay, one of the question here, limitation of auto transformer or disadvantages and disadvantage of auto transformer. So auto transformer cannot be used where perfect electrical isolation required between the source and the load. Auto transformer can't be used where perfect electrical isolation required between the source and the load. So ilant question adige chances untayi. What are the applications of auto transformer and limitations of auto transformers point of view? సో ఎక్కువ సార్లు ప్రాబ్లమ్స్ అడగాలన్నప్పుడు దీనిపైన క్వశ్చన్ అడుగుతాడు, సిరీస్ సబ్ట్రాక్టివ్ పొలారిటీ యాజ్ వెల్ యాజ్ ద సిరీస్ అడిటివ్ పొలారిటీ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్. నెక్స్ట్ క్వశ్చన్ ఎక్కడ అడిగే ఛాన్స్ ఉంటుందంటే ఈ ఈక్వేషన్స్ పైన అడుగుతాడు. సో దిస్ కేవీఏ రేటింగ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్స్. And next one, induction KVA and conduction KVA of auto transformer. So these 3 parameters, that is induction KVA and conduction KVA of auto transformer. So this was short notes in auto transformer concept. So all the short notes, limitation, application, equations in the series additive polarity of auto transformer, equations in series subtractive polarity of auto transformers. Okay. Let us solve some question based on this concept. Question number 1. A single phase transformer with a KVA rating K as voltage rating of V1 by V2. This transformation can be connected as auto transformer to get 2 possible voltage rating V1 plus V2 divided by V2 and V1 plus V2 divided by V1. The respective KVA rating of auto transformer are option 1 V1 plus V2 by V1 into K, V1 plus V2 by V2 into K, V1 plus V2 divided by K, V1 plus V2 by divided by K1 and V1 minus V2 divided by V1 into K, V1 minus V2 into V2, V1 plus V2 into by K, V1 plus V2 divided by V2 K. So these are the options for this question. And given in the question, given that the KVA rating of 2-winding transformer, KVA rating of 2-winding transformer, two-winding transformer, that is equal to K. Capital K is a KVA rating is given. And we know that transformation ratio of the auto transformer, transformation ratio of auto transformer is equal to low voltage of auto transformer divided by high voltage of auto transformer, high voltage of auto transformers part. And first combination, that is voltage rating of, okay, one is voltage rating of auto transformer. So one is given, so that is voltage rating of auto transformer point of view. So that is V1 plus V2 divided by So V2 is given. So this is the voltage rating of auto transformer. From this, okay, from this auto transformer, let us calculate small k, that is k auto transformer transformation ratio. Always low voltage of auto transformer means V2 divided by so V1 plus the V2 values. And how do we get KVA rating, respective KVA rating? The KVA rating of auto transformer is equal to 1 by 1 minus K times of the K terms of auto transformer multiplied by KVA rating of the two winding transformers one. And it is equal to KVA rating of auto transformer equal to 1 by 1 minus, where K value is equal to V2 by V1 plus V2 and multiplied by K, and by simplification you will get, so this is one is a V1 plus V2 divided by V1 the into K, so K of KVA rating of two winding transformer. And next case, second one is, let us calculate the second one also. And second is given that voltage rating of auto transformer, so that is V1 plus V2 divided by, so V1 plus V2 divided by, sorry, V1 is given, so this one is the V1. And from here we can get the transformation ratio of auto transformer is equal to low voltage of auto transformer divided by high voltage of auto transformer. Low voltage means V1 divided by V1 plus V2. And KVA rating of auto transformer is equal to 1 minus the K times of 1 minus a transformation ratio of auto transformer multiplied by KVA rating of the two winding transformer. So this value is equal to 1 by 1 minus V1 divided by V1 plus V2 multiplied by capital K. And by simplification here V1 will be cancelled out, that is V1 plus V2 the divided by, so V2 into K. So answer is V1 plus V2 by V1 into K, V1 plus V2 by V2 into K. So option 1 is correct for this question. And next let us solve another question. A 400 kVA, a 400 by 100 volts 10 kVA two winding transformer is reconnected as auto transformer across the suitable voltage source. The maximum rating of such transformer could be option 1 50 kVA, option 2 15 kVA, and option 3 12.5 kVA, and option 4 8.75 kVA. So now this is voltage rating and KVA rating of a two winding transformer. And possible connections point of view, suppose if it is connected like this manner, so there is a, I will tell you what all the possible connections which like a maximum KVA rating of such transformers one. And from here I am giving that applied voltage V1 and so the secondary voltage V2 and of auto transformer V1 of V2 and V1, and next one transformation ratio K, and also KVA rating of KVA of auto transformer, KVA of the KVA rating of auto transformer point of view. And first possible connection I am taking, so 400 volts as a source, 400 volts, and if it is connected in series additive polarity, this value will become, so that is 500 volt, where K is equal to low voltage by 400 divided by 500. And what is the transformation KVA rating of auto transformer? So KVA rating of auto transformer is equal to, so we know this formula, so 1 by 1 minus K into KVA rating of the two winding transformer. So this is the formula of the to find out the KVA rating. This is a one combination, and we will get here this one is the 0.00 cancel, 4 by 5 is the answer, and that is a 1 by 1 minus 4 by 5, so multiplied by 10. So now simplify this and it is equal to, so 5 into 10 kVA the is 10 kVA, so this is equal to 50 kVA. So here we got the 50 kVA. And here not mentioned 400 volts is a supply. ఈ క్వశ్చన్ లో 400 volts అని సప్లై there are 4 possibilities ఉంటాయి. ఒకటి ఇన్పుట్ వోల్టేజ్ 400 అనుకొని సిరీస్ ఆడిటివ్ పొలారిటీ కనెక్షన్ చేయడం, అండ్ ఇన్పుట్ వోల్టేజ్ 400 అనుకొని సిరీస్ సబ్ట్రాక్టివ్ పొలారిటీ కనెక్షన్ చేయడం. తర్వాత ఇన్పుట్ వోల్టేజ్ 100 అనుకొని సిరీస్ అడిటివ్ పొలారిటీ కనెక్షన్. ఇన్పుట్ వోల్టేజ్ 100 అనుకొని సిరీస్ ఆఫ్ సబ్ట్రాక్టివ్ పొలారిటీ కనెక్షన్. ఆ నాలుగిట్లో ఎక్కడ మ్యాక్సిమం కేవీఏ రేటింగ్ వస్తుందో వెరిఫై చేయాలి. అండ్ సెకండ్ కాంబినేషన్ తీసుకుంటే చూడండి, సెకండ్ కాంబినేషన్ ఐఎమ్ టేకింగ్ ఇన్పుట్ వోల్టేజ్ 400 volts బట్ కనెక్టెడ్ ఇన్ సిరీస్ సబ్ట్రాక్టివ్ పొలారిటీ. సబ్ట్రాక్టివ్ అన్నప్పుడు ఏమొస్తుంది, 400 minus 100 that is equal to 300 వస్తుంది. సో K is equal to ఏమొస్తుంది, లో వోల్టేజ్ బై డివైడెడ్ బై దిస్ లో వోల్టేజ్ ఒక బై హై వోల్టేజ్ అంటే దిస్ వాల్యూ ఈజ్ ఈక్వల్ టు 3/4 వస్తుంది. కేవీ రేటింగ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ ఈజ్ ఈక్వల్ టు 1/1 minus 3/4 అన్నప్పుడు ఎంత వస్తుంది, మల్టిప్లైడ్ బై 10 kVA. నా ఇట్ ఈస్ ఈక్వల్ టు సింప్లిఫై చేస్తే సో దట్ ఈస్ 4 into 10 kVA సో ఈక్వల్ టు 40 kVA అని వస్తుంది. సో ఇది ఒక క్వశ్చన్. అండ్ నెక్స్ట్ పాసిబిలిటీ, థర్డ్ పాసిబిలిటీ తీసుకుంటే, థర్డ్ పాసిబిలిటీ ఎలా అని, సో నేను ఇస్తున్నాను ఇన్పుట్ వోల్టేజ్ని 100 volts అనుకుంటాను. సో ఇక్కడ here V2 is nothing but here. So one is a series R2 polarity connection, series subtractive polarity. సో ఇలా సిరీస్ R2 polarity కనెక్షన్ చేసినాం అనుకోండి, అప్పుడు ఏమొస్తుంది, వోల్టేజ్ అనేది 500 volts వస్తుంది, 500 volts. సో అప్పుడు K is equal to ఏమొస్తుంది, సో 100 divided by 500. సో నౌ దిస్ ఈజ్ ఈక్వల్ టు క్యాన్సిల్ అయ్యి 1/5 వస్తుంది. నా కేవీ రేటింగ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ ఈజ్ ఈక్వల్ టు 1/1 minus 1/5. సో 1/5 అంటే సో మల్టిప్లైడ్ బై 10 kVA. సో నౌ దిస్ వాల్యూ ఈజ్ ఈక్వల్ టు సో 5/4 ద ఇంటూ ద 10 kVA అంటాను. సో 5/4 10 kVA అంటే దట్ ఈజ్ ఈక్వల్ టు 12.5 kVA ఆన్సర్ వస్తుంది. సో 12.5. అండ్ నెక్స్ట్ కాంబినేషన్లో సపోజ్ సేమ్ లో వోల్టేజ్ ఇన్పుట్ తీసుకున్నాను, ఈ వైండింగ్స్ను సిరీస్ సబ్ట్రాక్టివ్లో కనెక్ట్ చేసినప్పుడు వోల్టేజ్ ఎంత వస్తుంది, 300 volts అనేది వస్తుంది. అప్పుడు K ఈజ్ ఈక్వల్ టు సపోజ్ లో వోల్టేజ్ డివైడెడ్ బై హై వోల్టేజ్. సో దిస్ 0 zeros are cancelled, 1/3. Now KVA rating of auto transformer is equal to 1/1 minus 1/3 సో ఇంటూ 10 kVA అంటాను. సో 10 kVA అన్నప్పుడు ఎంత వస్తుంది ఇక్కడ, సో 3/2 అంటే 1.5 సో ఇంటూ 10 kVA ద ఈజ్ ఈక్వల్ టు 15 kVA అనేది వస్తుంది. సో ఈ విధంగా మనం వెరిఫై చేయాలి. సో ఇలా క్వశ్చన్ ఇవ్వనప్పుడు ఏది ఇన్పుట్ వోల్టేజ్ అన్నప్పుడు ఇక్కడ ఒకవేళ కేవీఏ రేటింగ్ ఫైండ్ అవుట్ చేయమని చెప్పలేదు, మ్యాక్సిమం కేవీఏ రేటింగ్ సచ్ ట్రాన్స్ఫార్మర్ కుడ్ బి అన్నాడు. సో ఇలా వెరిఫై చేసినప్పుడు ఏ కాంబినేషన్లో వస్తుంది, సో అంటే ఇన్పుట్ వోల్టేజ్ ఈజ్ కన్సిడర్ హై వోల్టేజ్ అండ్ వైండింగ్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్ అడిటివ్ పొలారిటీ కనెక్షన్. సో దిస్ ఈజ్ సిరీస్ ఒక అడిటివ్ పొలారిటీ, సిరీస్ అడిటివ్ పొలారిటీ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ and this series subtractive polarity of auto transformer, series additive polarity of auto transformer, series polarity polarity. ఇలా 4 combination verify చేసిన తర్వాత మనం we can verify the answer. So answer is the 50 kVA is the right answer for this question. Okay, and next question, question number 3. So ఎలా సాల్వ్ చేయాలంటే question number 3, an auto transformer having the transformation ratio of 0.8 supplies a load of 10 kilowatts. The power transferred inductively from the primary to the secondary side is option 1 10 kilowatts, option 2 8 kilowatts, option 3 2 kilowatts and option 4 is 0. So therefore induction power of auto transformer is equal to induction power of auto transformer, this is equal to 1 minus K times of the input power of the auto transformers, the input power. So 1 minus K is equal to 1 minus 0.8 multiplied by 10 kilowatts and it is equal to 0.2 into 10 kilowatts. So by solving this you will get the 2 kilowatts. So answer for this question, the 2 kilowatts is the right answer for this question. And next question number 4, in an auto transformer voltage ratio is V1 by V2 with V1 is greater than the V2. The conduction power in terms of the total power, option 1 is the V1 by V2, V2 by V1, V1 minus V2, V1 minus V2 by V1. And here auto transformer voltage rating is given, V1 is that. So let us calculate the K. K is the low voltage of auto transformer divided by high voltage of auto transformer, high voltage of auto transformer. So this value is equal to the low voltage, so V2 divided by V1, K value, and conduction kVA, conduction, the kVA is equal to K times of the input kVA of auto transformer. Conduction kVA of auto transformer is equal to the input kVA of auto transformer. This ratio we have to find. So therefore conduction power divided by, so conduction power of auto transformer divided by the total input power. So input power of auto transformer is equal to K, where K is V2 by the V1. So answer is option number 2 is correct for this question. And next question number 5. A 20 kVA 2300 upon 230 volts, the two winding transformer is to be used an auto transformer to give the 230 volts by 2530 volts. Its rating will be option 1 200 kVA with conducted kVA is equal to 200, and 200 kVA with conducted kVA is equal to 180, and 220 kVA with conduction kVA is equal to 20, 220 kVA, so with conduction kVA is equal to 200. So these are voltage rating and power rating of the two winding transformer, and it is given as auto transformer voltage rating. So this is auto transformer voltage. From auto transformer voltage rating you can find out the value of K. K is equal to, so that is low voltage of auto transformer, the divided by high voltage of auto transformer. The K is equal to low voltage. The low voltage is 2300 by 530. So this 2500, the 30 volts, this value is a K value, and from here suppose this is a K value only, and just substitute same as like. And next one, we have to find out kVA rating of auto transformer. How do we get kVA rating of auto transformer? kVA rating of auto transformer is equal to 1 by 1 minus K, the multiplied by into kVA rating of the two winding transformers. So this time kVA rating of auto transformer is equal to the 1 by 1 minus K. K is equal to 1 minus 2300 divided by 2530. So by simplification, kVA rating of two winding transformer is equal to 20 kVA, and this value is equal to, simplify here, and kVA rating of the two winding transformer is equal to, so 2530 divided by, so 2530 minus, okay, this one is the 2 minus 2000, the 300. So now this value is equal to the 230, so you will get the multiplied by 20 kVA. So by solving here we will get, so 220 kVA, and conduction kVA, suppose induction kVA is equal to the induction kVA of auto transformer always is equal to the kVA rating of two winding transformer, it is equal to 20 kVA. And suppose if you want to find out conduction kVA of auto transformer is equal to, and this 220 kVA minus the 20 kVA, so here the conduction, the 20 kVA, here you will get 200 kVA. So this is the answer for this question. So 220 kVA with conduction kVA is equal to the 200. So this type of the question. And next possibility of the questions here, single phase supply of the 220 volts 50 Hz is to obtained from the 400 volts 50 Hz source. The ratio of the conductor material in auto transformer winding to the that required to the two winding transformer is option 1 20 by 9, 9 by 20, 20 by 11, and 4 by so only option 4 is 2. And suppose we know that weight of the copper, weight of copper material, so weight of the copper material in that weight of the copper material in the two winding auto transformer is equal to auto transformer. So that is 1 minus K times of, so weight of the copper, so in the two winding transformer. Now we require the ratio of weight of the conductor material in two winding transformer, mind. So that value is equal to, so weight of the copper material is in the two winding transformer divided by weight of the copper material in auto transformer ratio. So it is equal to, so 1 by 1 minus K. So 1 by 1 minus K. Now simplify here, K is equal to 1 minus low voltage by the high voltage. So low voltage is equal to 220 divided by the 400. So by simplification, 400 the divided by 400 minus, so 220. So now it is equal to 400 divided by 180. So now it is equal to, so this 0 is a cancel. That 20 by 9 is the answer for this question. So that option 1 is correct. And next one, question number 7. A 400 upon 200 volts transformer has a full load voltage regulation of X per unit. Full load voltage regulation of X per unit at 0.8 power factor lagging. And if the transformer is used and transformer auto transformer with the voltage rating of 400 by the 600 volts or 600 200 by 600 volts, then voltage regulation would be x by 3 comma x by 3, 2x by 3 comma x by 3, 2x by 3 comma 2x by 3, x by 3 comma 2x by 3. Now first one, voltage rating of the full voltage. These are two winding transformer voltage rating, and these are the voltage rating of auto transformer. First case 1, the 400 volts divided by 600 volts auto transformer. And what is the value of the K? K is always low voltage of auto transformer divided by high voltage of auto transformers. The K అనేది ఎప్పుడు ఎలా అనుకోవాలా? Low voltage of auto transformer divided by high voltage of auto transformer. So now what is the value of low voltage of auto transformer? 400 divided by the 600. So this 0 is a cancel. The K is equal to 2 by 3. So after getting K, so we can find out the voltage regulation. Voltage regulation of auto transformer is equal to 1 minus K times of the voltage regulation of the two winding transformer. And what is the voltage regulation? That is the X value. So it is equal to 1 minus K value is equal to 2 by 3. So 2 by 3 values multiplied by X. So now simplification here, the X by 2. So this value is equal to X by 3. So in the case 1. And in case number 2, so then what will happen? See. Now the another voltage rating of, so 200 by 600 volts auto transformer we have. From this rating, let us calculate K, the transformation ratio of auto transformer. So that is equal to low voltage of auto transformer divided by high voltage of auto transformer, where K is equal to low voltage of auto transformer means the 200 divided by 600. So this 0 is a cancel. It is equal to 1 by 3. So 1 by 3. So therefore voltage rating of auto transformer is equal to 1 minus K into the voltage rating of the two winding transformer. So now this value is equal to 1 by 6 by 3. So into the X value. So simplify here. So now it is equal to 2x by 3. So answer for this question, option 4 is correct. And next let us solve question number 8. In an auto transformer, as V1, I1 as input quantities and V2, I2 as output quantities, V2 is less than V1, the VA conducted from the input output is, so conduction KVA is required. So first one, voltage rating is given, so voltage rating, so V2 less than V1. So from here we can find out V2, so value is equal to, so low voltage divided by the high voltage value, so V2 by V1 value, and VA conducted from the input to the output. So now induction KVA is equal to CR, induction KVA is required, and induction KVA is equal to 1 by 1 minus k, so 1 minus k multiplied by so input kVA of auto transformer. The 1 minus the V2 by V1 the multiplied by input kVA, the input kVA of auto transformer, so that is equal to V1 multiplied by I1, and by simplification here V1 minus V2 divided by V1, so into so V1 into I1. So V1 is cancelled out, it is equal to V1 I1 minus V2 and I1. This is the input induction kVA point. Now suppose what about conduction kVA? Is question about conduction kVA point of view. How do we get conduction kVA? K times of the input kVA of auto transformer. K is equal to V2 by, so this K is equal to V2 by V1, not V, or V2 by V1 value. So V2 by V1 multiplied by V1 into I1. V1 I1 is cancelled, the V2 into I1. So this V2 into I1, this is the I1 value. So V2 into I1. So option 1 is correct for this question. సో ఇలా మనకు ఈ కాన్సెప్ట్లో ఉండే క్వశ్చన్. జనరల్గా ఇలాంటి క్వశ్చన్స్ అడుగుతాడు. 2 వైండింగ్ ట్రాన్స్ఫార్మర్ యొక్క వోల్టేజ్ ఇచ్చేసి ఆటో ట్రాన్స్ఫార్మర్ యొక్క కేవీఏ రేటింగ్ కనుక్కోమని క్వశ్చన్ అడిగే ఛాన్సెస్ ఉంటాయి. సో నౌ in Saimedha Koti, how the videos are recorded, I will explain now. So basically online course recording, online course includes the first one topic wise video lectures, and second one topic wise previous gate bits explanations, and topic wise previous ESC bits explanation videos, and another one topic wise previous genco transco discom bits explanation videos, and fourth one topic wise previous UPSC bits explanation videos, and fifth one topic wise previous ISRO JTO DRDO bits explanation videos, topic wise previous TS PSC other state PSC bits explanation videos, and along with topic you will get topic wise live test, subject wise grand test, and also the full length live test. So complete content సో సాయిమేధ కోటి హైదరాబాద్ మీకు స్పేస్ గేట్ ద్వారా అందిస్తుంది. సో ఈ ప్రైస్ ఎంత ఉంటుందంటే చాలా తక్కువ ప్రైస్లో ఇంత మంచి కంటెంట్ను ఓన్లీ ఆన్లైన్ కోర్స్ తీసుకున్నట్లయితే ఓన్లీ 9,000 రూపీస్ మాత్రమే. మరి ఆన్లైన్ ప్లస్ ఆఫ్లైన్ కోర్స్ తీసుకున్నట్లయితే దీనికి 27,000 రూపీస్. అండ్ వీటితో పాటు ద 28th నుంచి న్యూ బ్యాచ్ స్టార్ట్ అవుతుంది. అది లైవ్ ప్లస్ రికార్డింగ్ ఉంటుంది. అంటే మీకు 3 బెనిఫిట్స్ ఉంటాయి. ఒకటి ప్రీ రికార్డెడ్ వీడియో లెక్చర్స్, నెక్స్ట్ లైవ్ ప్లస్ రికార్డింగ్ అండ్ మెటీరియల్ అండ్ ఆల్సో టెస్ట్ సిరీస్. ఇవంతా కూడా కంప్లీట్ సో 9,000 రూపీస్లో మీరు పొందవచ్చు. అండ్ ఇవన్నీ కూడా స్పేస్ గేట్ యాప్ ద్వారా మీరు స్పేస్ గేట్ యాప్ డౌన్లోడ్ చేసుకొని ఈ యాప్ డౌన్లోడ్ చేసుకున్న తర్వాత ఇక్కడ కనిపిస్తున్న నెంబర్ కాల్ చేస్తే సో మీరు ఎలా కోర్స్ అనేది పర్చేజ్ చేయాలనేది వివరించడం జరుగుతుంది. సో ఇది ద నెంబర్ 9849713451. ఇది శశికాంత్ వాల్మీకి సార్ నెంబర్. ఈ నెంబర్ కాల్ చేయండి. మీకు ఎలాంటి డౌట్స్ ఉన్నా కోర్స్ గురించి కానీ, తర్వాత యాప్లో ప్రీ రికార్డెడ్ వీడియోస్, టెస్ట్ సిరీస్, తర్వాత టెస్ట్ సిరీస్ ఏ విధంగా కండక్ట్ చేస్తాం, ఎలాంటి సబ్జెక్ట్స్, ఒక ఫస్ట్ సబ్జెక్ట్ ఇప్పుడు సిగ్నల్స్ అండ్ సిస్టమ్ నుంచి స్టార్ట్ అవుతుంది. సబ్జెక్ట్ వైజ్ కానీ ఎన్ని అవర్స్ ఇంకో సబ్జెక్ట్ వైజ్ ఉంటాయి, ఇవన్నీ కూడా సార్ మీకు వివరిస్తాడు. సో దిస్ వాజ్ ద డిస్కషన్ అబౌట్ the short notes and concept through the question in topic number 11 transformers. I hope you got it. Thank you very much.